This is AccuSizer software training on the topic of creating new calibration curves. Here is an overview to the process to create a new calibration curve. First, just to be careful, we're going to save the existing calibration curve or curves. And here's a warning, if you do this wrong, you could end up messing up your calibration curves and generating bad data, so let's be careful that we do this properly. Next, we're going to create a measurement protocol to measure various size standards. We'll measure those standards, and then we'll go into each result and we'll create something called a calibration region. After we've created all the calibration regions, we'll go into the software, create the new curve, save that calibration to a database, make sure we set up the new curve as our default curve to use for subsequent measurements, and then again we'll back up the new calibration curve just to be careful. It's up to you, the person performing the calibration, to choose which standards to be used, but we typically use these calibration kits that we get from micromeasurement labs. And we'll typically use between 12 and 14 standards to create the calibration curve for the summation mode, and 7 or 8 standards to create the extinction curve. But you can use any NIST traceable standards that would be acceptable. Inside the box of the calibration kit, you'll see here the dilution guidance. For instance, for these size ranges, we will inject 30 microliters of standard into 30 ml of filtered DI water. And then as we get to the larger size standards, for 10 microns and above, we'll inject between 100 and 350 microliters of the standard into 30 ml of water. We will then create the protocol and make a standard measurement for each of these PSL standards. Before we begin creating a new calibration curve, it's often a good idea to back up and make sure you know where your existing calibration curves are kept. So if we click on calibration, for the extinction we could click here. Let's save this calibration curve, and I'm keeping these under documents here, calibration curves. See the E, that tells me that is an extinction calibration curve. And I will do the same thing for the summation. I'll store that in the same file location. So before I get started, I always like to just make sure I have stored my existing calibration curves. When we're creating a new calibration curve, the first thing we will have done is the measurements of the various size standards we will use to create the calibration curve. After we've completed those measurements, we're going to come over into Sample Explorer, and I will open up an example here. For instance, here's a 25 micron standard that I analyzed. And the first thing I need to do is change the units on this graph. I come to Units, and I need to change this to being counts versus volts. Counts on the y-axis, volts on the x-axis. And what I'll do is right-click within the graph, select Regions, Add, and I'm going to add a calibration region. We need to use calibration regions for this function. And see this peak here goes from around 0.7 volts to 1 volt. I will enter those values here in the range. We'll go from 0.7 to 1.0. And down here where it says define region from mode within defined range, we click yes. The default value here is to go up 3 bins and down 3 bins from the mode. And then here we enter the particle size from the certificate of analysis for the standard we're using. This was a 25 micron standard. I click OK, and now you see we have defined this region, and if we right-click and go on Region Statistics, we will see that the mean voltage for the 25 micron standard is 0.950 volts. And these are the numbers that we will be using when we create the calibration curve. We need to repeat this process for each of the size standards we are using to create the calibration curve. You can see how I've created these calibration regions for each of these size ranges. After creating all of the calibration regions, we'll come up here and click on Calibration. And in Calibration, we will come over to the second tab, Create Calibration. And here we want to choose the instrument in the sensor mode. I'm going to create a new calibration curve in the extinction mode for operating an AccuSizer SIS system. In this area, we'll see the project within the Sample Explorer where the data is currently stored. And here we see the various results that we're going to use to create the calibration curve. Now that I've clicked in this region, you will notice that this blue Add Calibration Region button becomes active. And each time I click on that button, it will add a new calibration point to the curve. You'll see it added to the table here and added to the curve down below. And as I keep clicking on that blue Add Calibration Region button, we will populate this with all of the data that we created running the various particle size standards. So here's a table and a graph of the calibration curve. To save this, I want to add a caption, and I'll add something like, "This is an old sensor." And what's the calibration date is automatically filled in. The model here is the LE400. Enter the calibration serial number, whatever that might be. Sometimes I put an S or an E here to make sure I know it's extinction. I'll put EXT. The software will automatically add an E to the calibration name, but I might do this just to be certain I know if I'm working with extinction or summation. When I click Save Calibration to Database, it is saved. And now when I look up here to the various calibration curves, I see I have this sensor, and there's EXT to remind me this was extinction. So we saved this to the database. And now when we're going to use this system, we will make sure that when we come into the calibration manager, I make sure that I'm now going to use the most recent calibration curve, which I just called 1, 2, 3, 4, 5, old sensor EXT. And I need to also click here, Save Calibration to Database. Now when I operate the system, that is the calibration curve that will be the default that we will use for subsequent measurements. If I have old calibration curves in here, sometimes I could also click on these and remove them, so I make sure that I never use an old calibration curve. But before I do that, sometimes I take these calibration curves and I save them somewhere else to make sure I save all of my calibration curves, sometimes to an external drive, sometimes to a folder, and just make sure that I always have my calibration curves backed up. So now we've created a new calibration curve based on analyzing new standards.